All right, let's go over the solutions to the optional practice exam. If you took it, you should all be familiar. We're given two different particles, one moving along the y-axis, and it has the position y of t is 4t minus 2/3 at all times t, and the second particle q, which moves along the x-axis, and it has the position x of t is sine pi t divided by the quantity 2 minus t for all times t except at 2, because we'll get division by 0. So for part A, it wants us to, as t approaches 2, what is the limit of the position of the particle q, and show the work that leads to your answer. All right, so we're just taking the limit as t approaches 2 of this expression here. Now, on the AP exam, if you're going to use L'Hopital's rule, you want to show that you get 0 over 0 or infinity over infinity, or an infinity over another infinity. Otherwise, they don't give you full credit. But this goes to 0 over 0, and so you're going to apply L'Hopital's rule. And they want to make sure that you use the chain rule here. That's one of the things that they're looking for. Derivative of sine is cosine, so we get cosine pi t times the derivative of pi t, which is just pi, and then we get a negative 1. In the denominator, we take the derivative of 2 minus t. And we do direct substitution here. We're going to get negative cosine of 2 pi times pi, and you may remember cosine of 2 pi is just 1, so this works out to be just negative pi. All right, let's get on to letter B. So letter B, we want to show that the velocity of particle q is given by that expression there. So they often do this. If you need that velocity function at some later point, instead of just saying to find the velocity function, they'll give it to you and have you demonstrate what it equals. And the reason why they're doing that is so that if you can't do that properly, if you can't get the correct velocity function, then you can't do the later question that's going to require knowing that velocity function. So they do this sort of thing where they just have you prove it, so they give you the answer and have you show where it comes from. And that way, if you don't do it right, then you can still get the other later question correct. The other connection that they're making here is that you have to remember that the velocity function is the derivative of the position function, so they don't tell you to find x prime, they tell you to find the velocity. And so they're having you remember that relationship there. Of course, we need the quotient rule, so low d high minus high d low over low squared. Now, some of you, when you were doing this, you forgot the parentheses here, and algebraically that's not the same thing, and so you lost a point for that. So be careful for the little algebraic mistakes. The next thing we need to do is just do the algebra to get the expression that they got. And I'll be honest with you, I don't remember what they had, so I'm going to I think we just distribute this cosine pi t times pi to the 2 minus t. And so I end up with 2 pi cosine pi t minus, let's see, pi cosine pi t and all that times t, and then plus sine pi t. I didn't pay that close attention to what they had, so I'm going to have to go back and check to see if I've gotten to the point where they wanted me to get to. Yeah, the fact that the t is in a different location is not relevant to us. All right, let's get on to part C. And for part C, a lot of you misread part C or misunderstood. It says to find the rate of change of the distance between particle P and particle Q at t equals 1/2 and show the work that leads to your answer. Problem here is a lot of you used something that came up in an earlier, maybe a previous practice exam, where 2 points were vertical from each other, so it ended up being top function minus bottom function, and that's not happening here. Okay, so you have one object on the y-axis, one on the x-axis. They're very rarely going to be vertical from each other, and so we can't use just simple subtraction. we have to use the Pythagorean theorem to generate the relationship that we need to get the distance between them. So that's the problem that a lot of you had. So I want to call the distance between them d, so then it's going to have to be the x position squared. So d squared is going to be equal to x of t squared plus y of t squared. And so we would implicitly differentiate with respect to t here. And so we get 2 times d prime, whatever that happens to be, and then 2 times x of t times x prime of t, which is really just v of the velocity of the particle moving along the x-axis at that time, and then 2 times y of t times y prime of t. And we're doing this at t equals 1/2, so we have a bunch of information that we still need to go figure out so we can finish solving this. And I didn't think too closely about this ahead of time, so I'm going to have to do a little bit of thought here. Now, we haven't used y of t yet. That was just 4t minus 2/3. And so I need y prime of t, so I can put that up there. Y prime of t is going to be 4, okay, no matter what t is. So let's just do this right here. Y of 1/2 is going to be 4 times 1/2 minus 2/3, which is 2 minus 2/3, or 1 1/3, or 4/3 if you prefer the improper fraction. And then that's, well, y prime of 1/2 is still 4. You don't really need to rewrite that, but that's fine. What else do I need? I need to know x. So let's see. X of t is still this sine pi t over 2 minus t. And then x prime we had up there, which I don't really want to rewrite, so I'm not going to. I got it somewhere. It was kind of big, but let's do that at 1/2. Actually, let's do this one at 1/2 first. So x of 1/2 is going to be sine of 1/2 pi, sine of pi over 2, which hopefully you remember is just 1, but we'll get to that in just a moment, over 2 minus 1/2. So this is going to be 1 over 3/2, or just 2/3. Let me make sure I didn't make any. 4/2. Yeah, okay. And then down over here, what was our derivative? 2 pi cosine pi t. So 2 pi cosine pi over 2. And then pi cosine pi t times t, and it's minus pi cosine pi over 2 times 1/2. I'll have to double check. And then it was plus, or it was sine. Okay, so this would be sine of pi over 2. And then down here, we're going to have 2 minus 1/2 squared. Okay. Now, hopefully you remember that cosine of pi over 2 is 0. And so both of these terms go to 0. Sine of 1/2, as we said, is, sine of pi over 2 is 1. And then down here, we're going to have 3/2 squared, or 9/4, but it's reciprocal, so we'll use 4/9. And then I'm just going to have to figure out d. D is the only other thing I don't know at the moment here. So I'm looking for d prime. I didn't even write that down. Let me find the rate of change of the distance between them. Yes, we're trying to find d prime at t equals 1/2. I jumped right into solving the problem. I didn't even think about writing all that detail down. I apologize. So I still need to figure out d. We can use the Pythagorean theorem for that. So I got 4/3 for the y coordinate that I got to plug in, and 2/3 for the x coordinate. And so d squared is going to be equal to 4/3 squared plus 2/3 squared, or just 16/9 plus 4/9, which is 20/9. And so d is going to be the square root of 29ths. Wow, that's horrible. I'm assuming we're using the positive and maybe for the wrong reason. We're just doing distance between them, so yeah, we want the positive for that. Okay. And so now you just gotta plug all these values in to the right spot and then go from there. So I need 2 times the square root of 29ths times d prime. Actually, I'm gonna go back up here. I'm gonna ditch all the 2's. So all of these 2's here cancel. So I'm gonna get rid of those. So we got d times d prime. Okay, then I need x times x prime. And we said x was 2/3. And x prime was 4/9. And then it's going to be y, which is 4/3, times y prime, which is 4. And we just got to solve that for d prime. And you don't have to do any simplification here for this. You can if you want to, but they tell you not to in case you make a calculation error. But this is 8/27. And this is going to be 16/3. Why does that look wrong to me? But it might be right. And over the square root of 29ths. Hope I didn't make any of my own calculation errors there, but that's what you should get. Okay, for number 2, we have this cylinder, cylindrical barrel with a diameter of 2 feet. Contains collected rainwater as shown in the figure above. The water drains out through a valve not shown at the bottom of the barrel. The rate of change of the height of the water with respect to time. T is modeled by dH over dt is equal to -1/10 root h, where h is measured in feet, t is measured in seconds. The volume, they give us the volume, which you should all know, but they gave it to you anyways. Find the rate of change of the volume of water in the barrel with respect to time when the height of the water is 4 feet, and indicate units of measure. So, let's still recording, I hope. Okay. So the volume is area of the base, it's a circle, so pi r squared, times the height. Now, the problem that a lot of you had with this is you took the derivative wrong, okay? You took the derivative of r, and r is a constant. So a lot of you had 2 pi r dh over dt. No offense, but there's several things wrong with that. There's so much wrong with that if r is not a constant, then you'd have to do the product rule, okay? And a lot of you didn't. R is a constant, so then you don't even need to touch it. It's a constant multiple, so you don't change it to 2r. It stays as r squared. It's a constant. It's a number. Leave it alone, okay? And so when we take the derivative of the volume with respect to t, it should be just pi r squared times dH over dt. Now, you could have actually substituted in for r back before you took the derivative, because you could plug in for constants without any issue. They told us that the diameter was 2, and so that means the radius is 1, so dv over dt is going to be equal to just pi times dH over dt. Now, from there, we know dH over dt from at the top, so that's going to be pi times -1/10 times the square root of h. And I really forgot what we're doing at this point. We're trying to find the rate of change of the volume, but I don't remember what else. Rate of change of the volume when the height is 4 feet. Okay, so that's the part I'm missing. So we're finding, I guess, again, not getting so quick into this. We're trying to find dv over dt when h is equal to 4. Stuff I should probably start the problem with. And so dv over dt now is going to be pi times -1/10 times the square root of 4. Well, that's just 2/5, and it's negative times pi. I'm sorry, that's 2/10, which is 1/5. So let me go a little slower since I was going too fast and made a mistake. So it's negative pi over 5. And then it's rate of change of volume. I believe we're in feet for the height. So yes, so it's going to be cubic feet and times in seconds. So it's feet cubed per second as the units on that. All right, let's see if I can get back over here. This is when the height of the water is 3 feet, is the rate of change of the height of the water with respect to time increasing or decreasing. So a lot of people misread this, okay? So the key here to get this one correct, I paused, so I don't know where, that was an accidental pause. I'm not sure where I left off in my sentence, so I apologize for that. But some of you made a mistake because you misread the problem here. So this, I'm sorry, I'm trying to use one of the features here of the app, and it doesn't seem to want to let me. All right, never mind. I'm sorry. This is me trying to play a little bit with something. But when you read this, it says when the height of the water is 3 feet, is the rate of change of the height of the water with respect to time increasing or decreasing? A lot of you answered this as to whether h was increasing, and it's not asking us. It's asking us if h is increasing. It's asking us if h prime is increasing when h is equal to 3. Okay, increasing or decreasing. So I need to figure out dh, well, the second derivative of h with respect to time. So I know the first derivative of h with respect to time is negative 1/10 root h. And so the second derivative of h with respect to time is going to be negative 1/20th. Okay, because remember, this is negative 1/10 h to the 1/2. And so I'm going to bring the 1/2 as a multiplier. So negative 1/10 times 1/2 is negative 1/20th times h to the negative 1/2 times, because I'm differentiating with respect to t, times dh over dt. So this is actually negative 1/20 root h times dh over dt. And we know dh over dt, that's negative 1, well, this is negative 1/20th with root h in the bottom. And then this is negative 1/10 root h here. And then when you multiply these things together, the root h's cancel, the negatives cancel, and you get 1/200, which is greater than 0. So since dh squared is greater than 0, dh over dt is increasing when h equals 3. Actually, it doesn't even matter that h is equal to 3. We didn't need that as a factor. It's going to be increasing according to this, always. All right. Let's move on to the next. Part C says at t equals 0, the height of the water is 5. Use separation of variables to find an expression for h in terms of t. So let's see. dh over dt is negative 1/10 square root of h. And so when we separate the variables here, we're going to, now the negative 1/10 can go wherever you want the negative 1/10 to go. Let's overreacting. So you're going to have 1 over the square root of h times dh is equal to negative 1/10 dt, and then we'll integrate. In fact, I'm going to start doing the algebra here, but this is a negative 1/2 dh, and the integral negative 1/10 dt. And so now when I add 1 to the negative 1/2, I get a positive 1/2. When I divide by the positive 1/2, I'm going to get 2h to the 1/2. And then over here, we get negative 1/10 t plus c. It says in the solution guide, you get at most 2 points if you forget that plus c. And this is like a 4 or 5 point problem. I don't remember exactly how many off the top of my head, but you get a point for separating the variables and point for antiderivatives if you do that correctly. And then that's it if you have no plus c. So you lose out at least on 2 or 3 points. We know some initial condition, we're supposed to. T of 0, h is 5. Okay. So we got 0, 5. And so if I plug in 2 square root 5 over here will be equal to c. When I plug in 0 for t, it goes away. And so then I got 2h to the 1/2 equal to negative 1/10 t plus 2 root 5. And then solve for h. It does say to solve for h. Okay. So divide by 2 and we get this, and then square that. Like this. There's your answer. All right, so some of us forgot little things. This is an A-B heavy practice exam, but it kind of had to be because I've already used all the BC questions up that I had access to, so I had to give you some other stuff. But all the stuff is fair game, and they could ask you about it. So if you didn't do well, so be it. Let's try to do better going forward. Go study.